Welcome to this quick tutorial. We want to quickly look at conversion of bases, that is number base in base 10 numerals to binary. Now when we talk about that binary here is basically talking about base 2. So that binary deals with 2. So when you are talking about base 2, in converting any number in base 10 to base 2, that is binary, or any basis depending on what you are given in a question, divide by 2 and retrieve the remainder from the rear. Now that is grammar. Once you have a question like this, 47 base 10, I'm asked to convert it to binary. That is, I'm expected to divide 47, which is already in base 10. It is only a number in base 10 that you can convert to binary directly by dividing. So this is already in base 10. So if I'm going to work on this now, we are going to divide that 47 by 2. That is how we convert it to binary. And therefore, how do we do that? Just go with this number and this. So place 47 here. Then I'm dividing that 47 by 2. So if we use 2, how many times are you going to get 2 in 4? That will be 2 times. And again 2 in 7, 3, but it's remaining what? 1. That is 47 divided by 2 is going to be 23, remainder 1. That is 23 times 2 is 46, so remainder 1. This is the remainder 1. Again, you are still dividing by 2 because you are converting the number to binary. So 2 again, 23 divided by 2, if that is too much, how many times will you get 2 in 2? 1. How many times are we going to have 2 in 3? Also once. But here you are still having remainder what? Remainder 1. 11 times 2 will give you 22, and you have 23 here, so 1 is still remaining. Go again with 2 because you are converting to binary. 11 divided by 2, that is 5. You still have remainder 1. Then again 2 again, 5 divided by 2, I'm going to have 2 times, still remaining what? 1. Then we move to the next part. 2 divided by 2 is going to be 1. Remainder what? 0. Then again 2 divided by 1, that is impossible, so it's 0. Then remaining what? The number that you have here, which is 1. Now how do we take this? You read this up, put an arrow up, meaning that I'm going to start the reading of the number from the last part here, which is this. So I can now write it that, okay, 47 base 10 is the same thing. I start from this last number, 1 0 1 1 1 and 1 in base what? Base 2, which is binary. And in that same way, you've converted 47 in base 10 to base 2. Let's proceed to the next example. Still on that, I'm asked to convert 126 in base 10 to binary, which is base 2. So all I need to do is to divide 126 all through by 2. So write it out. 126 base 10 dividing it by base 2. This will be 2. Now go with this. How many times will you get 2 in 126? 126 is a whole lot of numbers. So start with how many times will I get 2 in 12? That is 6 times. Then how many times will I get 2 in 6 here? This 6 here. That is 3. It remains nothing. So 126 divided by 2 will give me 63. 63. Remainder nothing is 0. Again 2 again. How many times are you going to get 2 in 63? Start with this. How many times do we have 2 in 6? 2 in 6, 3 times. Then 2 in 3. How many 2 can you remove from 3? 1. And the number is still remaining what? 1, which is 63 divided by 2. The whole number will be 31. Then you have remainder 1. Then go again with 2. 2 in 3 once, but 1 is remaining here. Place it here. That becomes 11. So 31 divided by 2. That will give you 15. Remainder 1. Then go again with 2. 2 in 15 here. We give 2 in 15. You have it 7 times. 2 times 7 will give you 14. Remainder 1 again. Go with the next number again. 2. 2 in 7. That will be 3 times. Still remaining 1. Go with 2 again. 2 in 3. You have 1. Still remaining 1. Is that? Then lastly, 2 in 1 is not possible. So you write not possible 0. But what do we have as the remainder? The main number here is 1. So remaining 1. So what do I do at this point? You read up. We call this read up. Read up. That reading up simply means pick the values from the last part here up. So you can now write it down. Okay, 126 base 10 is same thing as start from the list. The last number there, 1 1 1 1 1 1 0. How many 1? 1 2 3 4 5 6. 1 2 3 4 5 6 with 0, and that is in base 2. So you have converted 126 base 10 to a number in base 2. So that has been converted. Now look at the evaluations here. Test yourself with few questions here. Convert 27 base 10 to binary. That means I'm expecting you to convert it to base 2. So base 2, you are expected to divide 27 by base 2, just as this example. 124 base 10 to binary, also divided by 2. 127 base 10 to binary, also by 2. Let's proceed to the next part. Now you are dealing with another conversion. Now conversion from denary to any base. Denary is talking about base 10. So once you see denary base 10, once you see binary is talking about base 2, while denary is talking about the base 10. So if I'm going to convert from base 10 to any base, it's still the same way. So I'll just look at what I have here. I'm asked to convert 41 base 10 to base 5. Now this number is already in base 10. So once you have a number in base 10, you can divide that number by any basis that is given in front of the number, provided that this number is in base 10. Watch, 41 base 10. So if I'm converting 41 base 10 to base 5 now, I'm going to divide 41 by 5 instead of 2. Now the base has been given as base 5. So how do I proceed with that? Now note, the procedure for conversion is like that of denary to binary. So you are just converting base 10 to base 2 also, but here now you are converting base 10 to a given base, any base that is given in front of the question. So in converting a denary number to any base, divide by that base and write the remainder from the last to the first. That is, after all the division, you read it up again. So at this point, pick this number again. We are working with 41 base 10 and dividing it by what? Base 5. So we are dividing by 5 here. So how many times will you see 5 in 41? 5 times 7 will give you 35. 5 times 8 will give you 40. So 40, remaining what? 1. That's 1. Then divide by 5 again. How many times will you pick out 5 from 8? 5 from 8 is still once, but we have remaining what? 3. Now you have divided by 5 again. How many times will you pick 5 from 1? It's impossible. That is 0. Now what is the number that is still remaining here? 1. So if you read this up, you can now have it that 41 base 10 is same thing as start from this part. 1 followed by 3 followed by 1, and that is in base what? Remember, you are not dealing with base 2 now, base 5. So you have it as base 5. Proceed to the next example. Also here, I'm asked to convert 243. Now this is a whole lot of big number now. 243 base 10 to base 8. Now look at the number that has been given in front of it, 8. So just write your 243. It's already in base 10. You are converting this to base 8. That means I'm expected to divide this by what? 8. So go with 24. 24 divided by 8. That is 243 divided by 8. So if you divide 24 by 8, it's going to go 3 times. And add 0 to this. So let's call it 30. 240 divided by 8. That will be 30. Then remaining what? 3. This is what I've done here. 243 divided by 8. You are going to get the whole number as 30. 8 times 30 will give you 240. 240 remaining 3. That is the 3 here. Again, 8 in 30. 8 times 1 is 8 times 2 16. 8 times 3 24. So if you have it 24 here, 3 times 8 times 3. So 8 in 30 will be 3 times. So 8 times 3 is 24. 24 subtracted from 30. 24 minus 30 or 30 minus 24. That is going to be remaining 6. Again, divided by 8. 8 in 3. You have 3. Remove 8. That's impossible. So you write impossible. Impossible is 0. Then what is the last number that's remaining here? 3. So what do we do here? Read this up. So therefore I can have it that, okay, 243 base 10 is the same thing as, read from the list, from this part, 3 followed by 6 followed by 3, and which is in base what? Base 8. So that is the conversion. So check all this again. Convert 127 base 10 to base 5. So you are expected to divide by 5. Convert 421 base 10 to base 5. You are still dividing by 5. Convert 321 base 10 to base 8. You are still dividing by 8. So